Hello, welcome back. Now we are going to see experiment number 9, parsing. Now we have to see the aim. Implement quicksort algorithm using recursive method. First you have to make element as pivot. In previous we are saying that same only we have to apply it here. The partial the array on the basis of pivot. Apply quicksort on left partition regressive and quicksort on right partition regressive. That same step of this before quicksort experiment that we want to apply it here. We have to see the size. We enter the size of the array. That asks the user to enter the size of array and say with input integer size. Assign ht as a non-array with size as length. We have to define a function hashing code with x as argument in the return x percentage size. Now we have to define a insert function with x as argument, assign object hc and call hashing code function. Now we have to see hash code x. Then we have to type return x percentage size. Now we have to insert x hc equal to hashing code x if ht hc double equal to none of ht hc double equal to -1. We have to see the if else in if the basics is ht hc double equal to none or -1. Now we have to see the else. T equal to hc plus 1 percentage size while ht equal to none and t equal to hc and htt equal to -1. Now we are going to see hash code function with x as argument using if condition. Check if is equal to none or ht is equal to -1. If yes, then assign as x else assign as size using while loop with condition not equal to none and t equal to hc and not equal to -1. Then assign and we have to assign t as t plus 1 percentage size using if condition. Check if t is print that hash table is full. Now we have to define a delete function with the x as argument. In that assign t as search function with x as argument using if condition. Check it ht is not equal to x. If yes, then print element not found, else assign ht as -1. Now we have to define a search function with x as argument in the assign hc as hash code function with x as argument using if condition. Check if hc is equal to x. If yes, then return hc using else if check it ht hc is equal to none, return minus and assigned as hc plus 1 percentage size using while loop with condition ht is not equal to none and not equal to hc and ht is not equal to x. Then assign t as t plus 1 percentage size using if condition. Define a display function in the open loop. Now we have to see delete. Define delete in that one variable x t equal to such x if ht t equal to x, print element not founded. Now we have to see the else ht t in equal to -1. Now we have to see the search hc is equal to hash coding, and if hc double equal to x, return hc, we have to see return minus 1, t equal to hc plus percentage size, while ht none, and t equal to hc and ht equal to x. Now we are going to see t equal to t plus 1 percentage size. If ht t double equal to x, double equal to x, then it will be return t. Then it will be return t. Now we have to see using a true while loop, using a true while loop, and then we have to insert one by one step, that like 5 steps: insert, delete, search, this, display, exit. Now we have to do this. Now we have to do this while true, and we have to print element is not position, else check if character is equal to 4. If yes, assign p to call and display function using else, check it character equal to 5 if yes, break. Break. Now we are going to see the output. We have to enter 3 array. We have to put insert, delete, search, display, and exit. It will be now it will be output 0, 1, 2, 3, 6, 5. That's all about this experiment. Experiment number 9. Hashing. Thank you.